Hey, everybody, we're just going to wait a couple more minutes for people to filter in, and then we'll get started. All right, everybody, just a couple more seconds, and then we'll get going. All right, I think we can get started. So hello, everybody. Welcome to week 3 of the OpenTofu Foundation series. My name is Dave. I'm the CTO at MassDriver. And today I'll be walking you through 6 sections. Each section is going to build on the previous. So what I'm going to do is walk through a section. I'm going to stop for questions, make sure all of the questions are answered, and then I'm going to move on to the next. Okay? So to start our course, we are going to talk about the basic types in OpenTofu, right? So the most basic type is null. Null is a weird one because it's the absence of value. Let's say you had a basket of 5 apples, and I said, hey, give me the 6th biggest apple. That 6th biggest apple doesn't exist. It's null. So null represents no value. You'll see this often if you've declared a variable, didn't set a default, and somebody didn't pass it into you. That variable will become null. And if you rely on that variable, it will likely break your system in some way, right? You're asking for a value. It doesn't exist. OpenTofu won't know what to do with that. So a declaration like this, where we say type any, which means anything, that is then not passed into OpenTofu, will result in null. The next simplest type is a Boolean. This is a simple true or false representation. So you want to know if a case is the same in one side or another, right? So if we say type equals bool, we set ourselves like a default. It would look something like true, or it could look like false. Simple 1 and 0. We will investigate this a little more when we go into conditionals. The next type to talk about is a number. Live coding, sorry. Numbers can look like whole numbers, like integers, or they can look like decimals. To Terraform, or not to Terraform, but to OpenTofu and Terraform as well, they're exactly the same. They're both numbers behind the scenes. So type number will accept either value. The next is a string. So we do variable string. Relying too much on syntax highlighting. Type equal to a string. So if we set a default here, strings are collections of characters that represent something kind of readable to a human being. So something like hello, right? It could be an ARN for AWS, something like that. Next, we have a more complex type. These are collection types. So the first one we're going to look at is a set. sets are collections of data that are of the same type, right? So you could have a set that looks like this, 1, 2, 3. You could have a set that looks like ABC. Notice that for this set to be valid, all data in the set needs to be the same type. In the event that you have a set where not everything is in the same type, behind the scenes, OpenTofu will actually look and typecast everything in that set. So this 1 here wouldn't be represented as a 1. It would be represented as a string with the character 1. The next type to talk about here is a list. Lists look almost exactly like sets with one major caveat. Your data doesn't have to be of the same type. But what a list does is behind the scenes creates a index for each element. So this element could be referenced by 0. This one could be referenced by 1. This one could be referenced by 2. Right? So sets don't have this. You can't access directly information in a set, but with lists you can. So we're going to look more at like how we access data in lists a little later in the webinar. And the last type we're going to cover is a map. We'll give it a default. So maps, if you've ever seen JSON or objects in like JavaScript, they look very, very similar. The syntax here, we have a index, which is a name. So we'll say name, and we'll give a name there. And then we will do, I don't know, occupation, engineer. So what this allows us to do is say, I want to access something just like a list, but instead of using a number, we've actually defined the access. So we can say, hey, I want this thing name, and it will spit out Dave. So these are the basic types in OpenTofu. I want to stop here because we're going to get into things we can do with these types in just a minute. Any questions? Does a number support scientific notation? I actually don't know the answer to that question. It sounds like you have a challenge for the end of the webinar. It is more or less safe. I think like when it comes to numbers, Go has a lot more types, right? They have unsigned ints, they have regular ints, they have floats, which are separate. So it's an abstraction over that Go type system. Other questions? No? Great. Now we're going to go into the fun part. So this week we're going to be introduced to a new concept, and that is our OpenTofu console. We can open that console by saying tofu console. And what this is going to do is if we have state, it's going to load our state in and allow us to kind of interact with like what the values are in our OpenTofu configuration, right? We can also run this with a plan. So if we want to pass some input variables in, we can say, okay, pass these input variables in, load it up, and now I can start seeing what the resources would do, right? So we have these variables defined here. And so we're just going to do some basic access of these variables. So if I say var map, oh, sorry, I have to save my configuration. We are going to reload our console here. Aha. Oh, sorry. We have to define our type here because, as I said before, sets are all defined with a single type. So we are going to type it's a set of strings. That is going to allow us to debug that. Okay, so let's take a look at what we've kind of configured here. If we say var.null, it says known after apply. The reason it says known after apply is because this is OpenTofu's very gentle way of saying, you didn't pass anything, it doesn't exist, I don't know what to do with this right now, right? Again, no. It's the non-existence of something. We look at var bool, we have true. We look at var number. I think I messed this up somehow. We're going to bypass it for the moment. Var string, we got hello. Var set. That's our set. Var list. There's our list. And finally, var.map. So as you can see, this console allows us to just access stuff that we've kind of set in OpenTofu and play around with it. We're going to use this to apply functions to these different data types and operations to these different data types. So let's talk about access. I told you before about our kind of special sets here, our sets, our lists, our maps. These are kind of types that hold data, right? So let's look at our set first. Let's look at var.set. Like I told you before, you can't access this data by any sort of like number index anything. So if I do this, you're going to see we get an error, right? This is literally just a collection of data to OpenTofu. If we look at the list, var list, and we say, give me the first thing in the list, we see that it's an A, right? Similarly, we can access it this way, and we get B. Our last kind of type here that we're going to play around with is our map. We can actually use dot notation here, so we can say var.map.name. So Dave. var.map.occupation engineer. You can access maps the same way you would access a list by just passing in the key name. So you have two options there with maps, either dot notation or you have this this square bracket index notation. Let's clear this. And let's go back in. So the first concept we're going to play around with in this console is the concept of operators. Operators are special functions that are represented in a different way from the rest of the built-in functions. They are a function that takes its arguments on either side of the operator, right? And we have a few classes of operators. The first class is math, basic math. So you could do something like 1. You could use the operator plus, and you could say 1, and you get 2, right? Similarly, we can do 1 times 1, which will be 1. 1 divided by 1, which will be 1. So these operators, you can see, are special characters with some value on either side. We have at our disposal equality operators. So equality operators will tell us if something is equal or not equal. So if we say 1 equals equals, oops. You'll see we get the Boolean true. If you say 1 does not equal 1, you'll see we get the Boolean operator or the Boolean value of false, right? So these are your two equality operators. These are really good to make sure that things are working the way you expect or that values are what you expect as you kind of move things around. Maybe you have like a condition, which we'll get into a little bit later. In addition to math and equality, we have comparison operators. So we can say things like 1 is greater than 2. That is obviously false. But if we say 2 is greater than 1, that is obviously true. So you have for your comparison operators, you have greater than, you have less than, you have greater than equal to, and you have less than equal to. These are the main ones you're going to see. And our last operator type is logic. So if you wanted to validate whether 2 conditions are true, you could do something like some case and another case, which is going to give you true. In the event that one of these cases is false, you can say false and true, which will give you false. This is all, I don't want to get too deep into how these logic operators work. That's something you should research, but this is just another kind of operator. I want to make sure that none of this is new to you when you see it in the wild. Let's find out. There are, this can be challenging. So that one will give you invalid operand. Some of these operands will do basically like typecasting to make the expression work. This is not an example of it. There's some documentation that'll be up in the walkthrough about some of those cases where OpenTofu can behave a little bit like JavaScript, where it's not, you're not exactly sure whether you're going to get the type matching or an error. Also, in your console, it's executing false. Interesting. But that's the high level of operators. Are there any other questions besides the type matching? We got to reload for clear console. Nope, it looks like we're ready to move on. Awesome. So now I want to get into some built-in functions in OpenTofu that I see often and kind of like how to use them. So the first one we're going to take a look at is split. So to use a function, what you'll do is you'll type the function name. You'll pass its arguments. So in this case, split takes 2. It takes something that's going to be a delimiter on your string. It's going to take a string. So we can do 1, 2, 3. And we're going to close our parentheses. So we have our variable that we're invoking. We have parentheses to say, now I'm going to pass you my arguments. And split takes 2, our delimiter. So it's going to look for every comma in a string. And it's going to give us a list in return of each element that's split by this function. So if we hit enter here, you'll see we have a list with 1, 2, and 3. Notice it splits on the comma. It doesn't add the comma back into the string. This is very common for maybe taking input that's not a traditional Terraform list. Maybe you're hitting an API that's giving you back comma-separated strings. So split's really interesting here. We'll have a use case later on where we kind of look at a practical use case of split. Now, the opposite of split is join. Join allows us to take a list and make a string. So if I do the same thing here, we say string 1, string 2, string 3. What we're going to do is we're going to take every element within this list, and we're going to join it into a string with that delimiter as the thing that separates each element. So if we hit enter here, we get the string 1, 2, 3. Okay, we're still talking about that. Awesome. Then another useful function is replace. Replace allows us to take a string and make some modifications. This is often done to like clean up some data, right? Maybe we want to remove special characters or something like that. So what we can do is we can say replace. We can give it a string. So let's just say 1 + 2 + 3. And then we can say, I don't want the character plus anymore. And instead, I actually want a dash. If we hit this, we expect to see 1 - 2 - 3. So very common in cleaning up strings, removing characters that you know are going to cause problems. Similar to the problem of cleaning up strings, we have the trim function. The trim function will allow us to take a string and remove characters that like we don't want in this, and it'll remove from both the beginning and the end. So here we're saying any empty space, let's remove it from either side of our string here. So we'll want a space there. So any empty space, remove it, and it just gives us the string hello. There are functions for trimming just from the front and from the back. All of those will be referenced. There'll be links to the documentation for these functions in the walkthrough, and that'll have all of the related functions on the sidebar that you can kind of explore. Another useful function is parseInt. So again, we call our function, we open our parens. What parseInt does is it takes a string that is a number that we actually want a real number from. So maybe an API is returning you the string 100, but some other resource in OpenTofu requires an actual number. You'll have a type error if you don't, well, OpenTofu might do some casting, but again, leaving that stuff to chance is not what you want to do. So here we can actually say we want parseInt, and we want it to be a base 10 number. When we hit parseInt, it gives us the number 100. This one's really, really useful. Again, leaving typecasting to chance is not the way to go. You always want to make sure you're validating input and validating things that are being passed between resources. Interesting question. Trims spaces. Let's find out. Let's do trim. Let's put in tab. Hello. Let's say we want to trim \t, and let's see what happens. There you go. It trims tabs. You're going to see later on we're gonna use some of that kind of stuff for splitting a string. So we're going to split strings on new lines. So I think most of this can handle that. Let's look at the next useful function. I see this quite a bit. It's the function coalesce. So coalesce is a really neat function. It allows you to look at two values and say, if the first value doesn't exist, I would like to, use this other value, right? So it's almost like setting a fallback, right? So you can do this when like a variable is optional. If the variable didn't come in, let's use this other thing. So for coalesce, if I say evaluate this string, and if not, evaluate fallback, we're going to get string hello. If I make that string empty, what you're going to see is fallback. So coalesce is looking and says, that empty string is not a value that's useful. Let's use fallback instead. Again, we use this a lot when it comes to like optional variables and things like that. You're going to get a lot more of that next week when we talk about dynamic blocks and things like that. This is where this stuff really comes into play and is really, really important. On to some list functions. This is compact. Compact is an interesting one. What it can do is make your lists more usable by filtering out data that you might not necessarily want. So if I say compact to this list that has like some string values, it has some empty strings, it has null, what happens is we filter out that null and we filter out that empty string, right? So we're just saying take the values from this. This could happen if you run a map function on something that doesn't return a result and instead injects nil or an empty string. Compact is really useful for making sure that whatever you get back, we have a list that is usable and iteratable. Similarly, we have distinct. So distinct is great for saying, like, I may get a list that has a bunch of values that are repeated. C and D. What we expect now is we hit enter, we're actually going to get a compacted list that gives us A, B, C, D. So it filtered out that extra A, it filtered out that extra C, right? Again, with lists, you can end up needing only the unique values and not every single value that was returned. So distinct is a really helpful function. Another really great one is toString. Like parseInt, sometimes you're going to get numbers back from things that you didn't expect or that need to be a string somewhere else, right? Maybe it needs to be injected into JSON and you don't want to leave typecasting to chance. If we do toString 20, we get string 20. Let's look at some other fun stuff. Length is an interesting function. Length is a function that can take many types. So if we do length with a string, it can give us the number of characters in a string. If we do length with an array or a list, it can give us the number of elements within that list. So length is pretty unique in that it can take many types and give you usable information back. Here's another one for you. Let's look at JSON encode. So JSON encode is really cool for readability, right? So there are specific times when dealing with OpenTofu, you can think about like making IAM roles and things like that, where the provider wants a JSON string. But JSON strings are hard to look at, right? You want to use kind of the native types within OpenTofu. So what we can do is we can create an object. Again, we can say name equals Dave. This is all the native OpenTofu map object syntax. And what JSON encode does is give you that encoded as a string. This is really, really useful for readability. That native object declaration looks a lot cleaner than having to parse a string like this. So JSON encode is your best friend here. The last function that we are going to cover is try. Try is a safeguard. So what try will do is it will attempt to evaluate an expression. So you're going to pass it an expression. And if it doesn't work, it's going to move on to the next thing you pass it. So if we say something like bar.list, and we're going to say, give me the fourth element in list. What's going to happen is there's no fourth element, and it's going to throw an error. But because we draft it in try, what it'll do is it'll then move on to the next expression we pass it, and we say, actually, give me 0 here. Again, if I do bar list 4 without the try, it's going to throw me an error. So try allows you to evaluate multiple expressions. Again, try is a useful function when you start to get into like optional inputs, right? So maybe you have some option to, you know, build a log bucket with a module, right? And if somebody says, I don't want the log bucket, that's great. Everything will work. If they say that they do want the log bucket, or sorry, if they say they do want the log bucket, everything's fine. But if they don't, there's still some code that's going to evaluate. So you want to make sure that you're using try to abandon or default those attempts to like evaluate an expression that maybe doesn't exist or will error. So that's kind of like a tour of functions and things that we can use. I want to pause there and kind of talk through any questions that you might have about how to use functions. Terry, there is an itrim and rtrim. It's not called that though. I think it's trim prefix and trim suffix. I don't. Let's look at this question. I don't know the upper limit of function nesting. I will tell you that as somebody who has to read OpenTofu, the upper limit is like 2 for me before I kind of get mad that I have to read this. We will get into some like local stuff a little bit later, where you can see what it looks like to nest a lot of this stuff, and that there is an upper limit that the eye can handle, and it's much earlier than what OpenTofu can handle. Any other questions on functions? Awesome. So we've learned a little bit about functions. We've learned a little bit about types. Let's talk about some control structures. So generally, control structures are they're expressions that allow us to fork our code, right? It allows us to say, is something true, right? So we take a case and we say, if it is, do this. If it's not, do that. There is an if expression in OpenTofu, but it's used in kind of special circumstances. Generally, the thing we're going to use is called a ternary expression, right? And how that looks is we have some kind of a case, right? In this case, we're going to say case true. You put a question mark. Now, we put in what we want to happen. So we're going to say we want to return hello in the event that the case is true. And if the case is not true, we want to say world. When we evaluate this, you'll see we get the value hello. If we flip the case and we make it false, you'll see that we get world, right? So again, talking about dynamic blocks, talking about kind of all this protective stuff you do, ternaries are your best friend here to kind of say like, maybe something could be this way. And if it is, we want to do this. And if it's not, we want to do that. This is all over OpenTofu modules. You'll see it all over the place. It's a really common idiom. Using the if is kind of interesting. The place that we use the if is in things called list comprehensions, which we're going to go over next, but I just kind of want you to see the syntax first. So I'm not going to get into this, but I'm going to say, I'm going to call a function. We're going to say upper S, and we're going to say do that if S does not equal an empty string. And when we run this, you'll see everything went, right? If we change and we say B is going to be an empty string, what you're going to see is an uppercase A and a C, right? So if doesn't do kind of the traditional if-else thing that you see in other languages. It's really like a should this happen or should we just skip? And you mostly see it in these comprehensions, which again, we're going to go over in just a minute what this syntax is. But I just want you to see how if is used in OpenTofu. Questions on ternaries and ifs. Is that clear to everybody? Awesome. Awesome. Let's move on. So obviously I just said we're looking at comprehensions, and we're going to talk about what a comprehension is. So comprehensions, which you see often in Python, if anybody has experience in Python, they allow you to iterate through a list and perform some action on some data and return a brand new list. So let's look at the kind of structure of a comprehension. So the first thing we do is we do brackets. What these outside brackets mean is whatever the evaluation of our little kind of function is, we want the value to be returned as an element within a list, right? We're going to actually see how to go back and forth and change our data type. But for now, let's just say we're going from a list to a list. So the next thing we have to do is say for some variable, in this case, we'll call it X or S, in some list. So we'll define a list just like we did before. C. And to make this simpler, we'll fill out every value. We won't do a condition. So the next thing you're going to do is a colon. What the colon says is like, all right, now we know what we're iterating through and what we're calling each piece of the iteration. The colon says, now let's start to do something with this, right? And so again, if I just do upper S, what we end up with is a new list where we went through each item in the list and we ran some function. If we had a list of numbers, 2, 3, and we said, turn us S times 2. You can see here, we've gone through every item in the list and we've multiplied by 2. So this is really great if you want to take a list and then make a new list out of the data there. So Yes, I've used list comprehensions extensively in OpenTofu and in Terraform. It's really, really common, especially when you have complex inputs. I never nest them because I do think that's really, really hard to read. But like I've seen it done, and sometimes it is necessary. So you can actually nest those comprehensions like in Python. So let's look at an example of converting a list to a map, right? So what we can do is, again, we define the type that we want returned with our kind of outside enclosures. So here we're going to use 2 curly braces, which says I want an object. The syntax is going to be very, very similar. We're going to say for S in A, B, and C. We want to do, we're going to say we want a capital letter as our key. And we're going to say we want the lowercase letter to be our value. And if we click enter here, you can see what we end up with is a map where an uppercase is our key and a lowercase is our value. So now we can say, I would like A to be returned from this. You can see it gives us lowercase a. So those are comprehensions in a nutshell. Complex to look at, but if you use it a couple of times, it becomes really, really familiar really fast. Any questions on that? Yeah, this is an interesting statement. So there is a lot of, this is where things can get dangerous and why like using functions and intense validation is really, really important. If you leave it to chance, you may be surprised whether or not typecasting works, whether things end up the right type. So again, as much validation as you can do on information coming in, the better, because there are some places where it's unpredictable what's going to happen. Any other questions before we get into something absolutely crazy? No? Great. So let us exit this. One of the kind of exclusive features to OpenTofu is your ability to make your own functions with Go. All of this code is going to be made available on the GitHub. As soon as this webinar is over, I'm gonna add some challenges to it too. So don't worry about typing it in. I just want to give you a tour of what it's like to build your own functionality. But before we start that, a word of warning. One, the provider we're going to look at is in beta. So it's fun to experiment, but we should wait a little bit before we put this in production. But the other thing is, like, before you decide that you need to build your own functionality, the provider ecosystem is incredibly rich. There's everything from like running JQ functions on some JSON to like ordering a Domino's pizza. So before you decide you want to embark on the journey we're about to embark on, I would highly recommend really looking at the provider ecosystem to see if anybody else has solved your problem and if anybody else has tested that. So without further ado, let's take a look at what it's like to build your own function using the Go provider in OpenTofu. Oops, didn't mean to change that. So in order to start this, we need to define a provider. And our provider is going to be the Go provider here. And you can find it at registry.opentofu.org, opentofu.go. So if we go in here and say tofu init, that will install the provider for us. I want to take a look at kind of an overview of main. The only thing we should look at right now is the fact that you need to say, hey, provider go, and you need to give it a file name for where your Golang code is going to live. It should always be a lib file. So you're always gonna kind of paste this exact same thing. It needs to be called .lib. If we follow that path, we have this lib.go file, where again, we say it's package lib. So that's the basics. That's how we get the provider in there and get it ready to start reading Go. I want to talk a little bit about what we're going to try and do here. This is convoluted, but I think it's fun and it shows you what we can do with Go. So if you look at main TF here, you'll see I've defined some locals. Don't worry too much about what locals are. You're going to get into that next week, but just know it's a place for us to store some information that's not coming in from the outside, right? We get to define a variable and its value in the same place. And we're actually going to take that user data string that we had from weeks 1 and 2. And our goal is going to be to add a new environment variable. And the environment variable is going to be the Federal Reserve's record of what the Canadian dollar to USD exchange rate is, right? And so to do that, we're going to use Go to hit the Federal Reserve API, get that exchange rate, and then we're going to inject it in here using some functions in OpenTofu. Sound fun? Awesome. So let me walk you through the code, right? The first objective that we have is actually going to get this data. And this is where we're going to use that Go provider. So we've defined a variable here called record. And we're going to invoke it using provider, : go, : function name. Important note here, it doesn't recognize camel case. So everything will always be lowercase for the entire function name. It took me a while to figure that out. I kept getting errors. That is kind of the difference there. Yes, exactly. It's not a Terraform resource though. This is just a function that's being called. Oh, thank you. I'll shout that out real quick. Love the fact that somebody's listening to Doom. Okay. So let's take a look at the Go code and see what's going on right now. So I don't want to make this like a Go lecture. Learning Go is really important, especially if you're in operations. You should look up Learn Go with tests if you don't currently know it. It's the best way to learn a language, to be honest with you. It's super fun. I do it, every 2 or 3 months just to like keep my chops sharp. So here's what we're going to do. Here's our base URL for the US Treasury and the path that we're going to need to go to get our data. We're just declaring that as a variable. What you're going to see here is some struct declarations. All these are doing is setting up objects that allow us to parse the JSON return from the API to some Go type. So then we can manipulate it however we want. You can see here we have a response. That response has an array of records, and it has some metadata, which is an object, which we've defined here. So a record has the currency type, it has the exchange rate, and then it has the date that it was recorded. Metadata is not important. We're not really going to use it here, but all of the fields that are going to come back are represented here. So again, we have a full object to represent the response. And finally, we have a type, which is request options. This is like really common in Go. You'll see like input objects, right, to give you like really good type safe validation on things that are coming in. So we've defined one where our field is currencies, and you'll see here this annotation. What this annotation is it says, I'm going to get an object in from Terraform, and the field that I'm going to assign to this property is going to be currencies. So if we cut back to main.go or main.tf, you'll see here I'm providing an object. That object has a currencies attribute, and we're going to say Canada dollar because that's what the API expects. A really good challenge here might be to take a look at what other currencies are available on this on the Federal Reserve API and make validation to confirm that like an acceptable currency has been passed in. So back to our lib.go. So what's going to happen is Canada dollar is going to come in. It's going to be assigned to currencies. So now here's our function that we're actually building, right? So we have a function called exchange rate. It's going to take in an attribute called options, and it is a type of request options. And what it's going to return is a single record from this data. So by default, you can request the exchange rate for the Canadian dollar. And in that data array, each entry that it has will return you a different record going back in time. We only care about the most recent one, right? Like if we wanted to use this environment variable to show Canadians what the price of a product is in Canadian dollars, we would only care about the most recent, right? In this function, we define a variable of type response. So this is where we're actually going to put our response from the request to the API. We define some query params. Again, this will all be in the code. I think the PR was shared, but it's a lot. Important to note, we're sorting by the record date descending. So we want the most recent one. And we're saying that the page size is going to be 1. So it means I want 1 entry. So I want the 1 most recent entry. So we're not pulling back a ton of data from their server. And then the country currencies, we're actually giving, we're going to inject a variable in here, and that will be our option.currencies, right? So this is going to become Canadian dollar, right? It could be Mexican peso. It could be any number of other currency types that are supported by the API. But for this one, we're going to use Canadian dollar. Request URL here actually takes the base URL and all of our params and combines it all together so we can make a request to the API with all of the right information. And we're going to make that request, and we're going to get a response, and we're going to get an error. Hopefully that error is null, which we're going to check, or nil, which we're going to check for here. If it's not, we're going to fail, and we're going to say our OpenTofu can't run because there was a critical failure here. But in the event that this error doesn't exist, we're going to take the response, we're going to read the body, and we're going to do the same process here. We're going to assign the body, and we're going to check for an error. And finally, we're going to take that body's JSON, and we're going to assign it to a response here. So what that should give us is a giant Go struct that represents the response we got back from the API. And finally, because all we care about is the currency, the exchange rate, and the date that this was created, we're only going to return that first element of the data response to OpenTofu here from Go. So that was a long explanation. It's a lot of code. Does everybody kind of get like what's going to happen here? Are there any questions about like what we expect to happen? No, we're good. Great. Awesome. So let's go back to main TF. We now know what this is going to spit out. It's going to spit out something that looks like exchange rate equals 1.26 something, right? Created at, and currency, so on and so forth, right? And we're going to be able to say like record dot exchange rate and get that exchange rate that was returned from the API. So let's talk about what to do. We have another problem which functions will help us solve. One is that we have this user data string. And this string needs to be manipulated. We actually need to inject something into the middle of it, right? So we can actually use some of those functions we saw earlier to set us up to do this. So the first thing we're going to do is we're gonna declare the string that we want to inject, right? And so what we're going to do is inject another environment variable called CAD exchange rate, and we want to use that variable we defined, record.exchange rate. right? So that'll end up being cat exchange rate equals like 1.26 or some number like that. And we want to say new line at the end of it because, again, we want it to look exactly like this, right? We want it to end up being equals 1.26, like that, right? So it doesn't break when we inject it into user data. So let's talk about how we can go about solving the problem of like injecting something into this string that was passed in. Well, the first thing we can do is we can use split to say, I want to split on every new line. So each line becomes, part of a list. That's why, right? And we can iterate through and do things and put stuff in this list in the order that we want so we can spit it back out. So you see here, we're using split. We're saying split on every new line. And then because a multi-line string is coming in, we're using that toString function to say inject back in those new line characters. Otherwise, this won't parse correctly. Once we have that kind of split up user data, we'll have a list of all of this stuff. So let's go and say, let's do split user data. And let's do tofu apply auto approve and see what comes out there. This is to be expected. The API for the Federal Reserve is flaky, so sometimes we get back weird responses. There you go. So you'll see here, we have a list. Each line of that user data script is now a single element in that list. We could say something like, just give me the first element of that list. Oh, there you go. And so if you see the changes here, it goes from the output being that list to just the first line. Cool. So now we have a list that we can work with and we can start to split apart. Let's look at the next piece of this. So here, what we're going to do is we want to actually like destructure the list that we got back. So this function here, slice, what it allows us to do is say, give me a list, right? And with that list, take a certain number of elements and make me a new list with just those elements, right? So here we're saying slice, take the split user data variable, give me from the first element to the 9th element, and make that a list in this list. Next, we're taking that variable that we defined, which is the string that we want to be injected into our multi-line string. And we're saying, finally, give me the last piece of this. So what that'll allow us to do is say, we have one list that is this, and we have an entry that's going to be the 9th element, and then we have the existing 10th element that we want to add in. So now we have this kind of structure. Let's take a look at how that looks. If we go down to value and we can say local.parsed user data, save it. We do our tofu apply auto approve. We got our flaky output. I wonder if I'm now being okay. For the sake of time, I'm going to try this one more time, and then I'm going to kind of go around it. There you go. So what we have is we have a list, which is all of the kind of things before we want to inject. And then we have two individual values, right, that are going to kind of, we're going to want to be, sequential after that initial list. So from this data, we can use our join function, right? So we can say, I want to take that list, and I want to join every element in it with a new line, right? So it goes back to that kind of original format that we saw. And we're going to use, again, nested. We're going to use a nested function here just because it's easy enough to kind of look at. And we're going to use the flatten function on this kind of array of arrays and values. And so what that's going to do is it's going to go through a list, and it's going to, if there is a list in one of the elements, it's actually going to take every element and make it kind of first class in the list. And if it's just a value, it's going to be, it's going to remain kind of where it is. So if we look at what that does, we can say flatten that. I think the plan told us what it's going to be, though. Maybe. Yeah, it did. The plan told us. One element. One. Let's see if we can do it again. Come on. And it's giving us no changes because it already did that. But if we look here, one element will be hidden, but we can get a sense, right? Thank you for auto. So again, so we look at that list, and now this used to be a list, right, with two values, and now it's moved it all up to first class, right? I believe so. I would take a look at the documentation for functions. I couldn't think of it off the top of my head. I was trying to do something convoluted that used really basic functions, but I would definitely check that out. All right. And finally, so now that we've kind of flattened that out and we've decided we wanted to join with our new line, let's take a look at what our output will be for joined user data. Whoops. Joined user data. Did it give us the output anyway? Oh, try it again. Again, this is this is a flaky API. So we are getting some issues here, but there you go. We finally got it. So our final joined output is a multi-line string with the Canadian exchange rate of 1.352. So this is a lot. What other questions can I answer? This is something that I would explore. It gets into kind of like the basics of programming. So if you have limited programming experience, I highly recommend Learn Go with tests and playing around with this, seeing if you can kind of like do this with a different API. Can you get a single value from a different API? But yeah, this has been an introduction to functions and building your own functions. Hope you've all enjoyed it. Thanks for coming.